Hello Tade, we are going to start a course which is graphics. This is first module of course in which we are going to learn introduction to graphics. In module 1, what is computer graphics? Graphics hardware and software of graphics pipeline vector versus raster graphics. Basic graphics programming concepts. Computer graphics refers to the creation, manipulation, and display of images and visual content using computer technology. It involves the use of software tools and techniques to generate digital images, animations, and video content that can be used in a variety of contexts such as video games, movies, advertising, design, and scientific visualization. Computer graphics encompasses a wide range of topics including 2D and 3D graphics, image processing, computer vision, virtual and augmented reality, and human-computer interaction. It involves the use of algorithms and mathematical models to simulate the behavior of light, materials, and surfaces, and to create realistic or stylized images that convey information or express artistic intent. Computer graphics has revolutionized many fields, from entertainment to education to medicine, by providing powerful tools for visualization and communication. It has enabled the creation of immersive virtual environments, interactive simulations, and digital art that can engage and inspire audiences in new ways. Graphics hardware and software are essential components of computer graphics which enable the creation, processing, and display of digital images, animations, and video content. Graphics hardware includes the physical components of a computer system that are responsible for generating and displaying images on a screen. This includes the graphics processing unit GPU, which is a specialized processor designed to perform the complex calculations required for graphics rendering. GPS are typically used for 3D rendering, gaming, and other applications that require high-speed processing and real-time graphics performance. Other important components of graphics hardware include the display, input devices such as keyboards and mice, and data storage devices. Graphics software refers to the programs and tools used to create, edit, and manipulate digital images, animations, and video content. This includes 2D and 3D modeling software, image processing software, animation software, video editing software, and more. Graphics software allows artists, designers, and engineers to create and manipulate digital content in a variety of formats, from static images to complex animations and interactive simulations. Both graphics hardware and software have evolved rapidly over the years, enabling new possibilities in computer graphics and pushing the boundaries of what is possible in terms of visual quality and performance. As a result, computer graphics has become an essential tool in many industries, including entertainment, advertising, design, architecture, and science. The graphics pipeline refers to the sequence of steps that a computer system goes through to create and display a visual image on a screen. The graphics pipeline typically consists of several stages, each of which performs a specific function in the process of generating and rendering a 3D image. The basic stages of the graphics pipeline include 1. Geometry processing. In this stage, the 3D models are transformed and processed to create a 3D representation of the object in virtual space. This may involve operations such as scaling, rotation, translation, and projection. 2. Rasterization. In this stage, the 3D models are converted into a 2D image by projecting the geometry onto a 2D plane. This is done by dividing the geometry into small triangles and calculating the colors and textures for each pixel in the triangle. 3. Fragment shading. In this stage, the colors and textures are calculated for each fragment of the 2D image based on the lighting and material properties of the object being rendered. 4. Pixel processing. In this stage, The final colors and values for each pixel are computed based on any post-processing effects or anti-aliasing techniques that are being applied. 5. Display. Finally, the image is displayed on the screen. There may be additional stages or variations of the graphics pipeline, depending on the specific hardware and software being used. However, the basic stages outlined above form the core of the graphics pipeline and are used in most modern computer graphics systems. Vector and raster graphics are two different types of digital images that are used in computer graphics and design. Raster graphics, also known as bitmap graphics, are composed of a grid of pixels, each of which contains a specific color value. The resolution of a raster image is determined by the number of pixels it contains, and increasing the resolution of a raster image can result in loss of quality or pixelation. Examples of raster graphics include photographs and scan images. Raster images are commonly used for creating realistic or photographic images, but they may not scale well and may be limited in terms of editing and manipulation capabilities. Vector graphics, on the other hand, are composed of mathematical shapes and curves that are defined by lines and points. Known as vectors, vector graphics are resolution independent, meaning they can be scaled up or down without losing quality. They are typically used for creating logos, illustrations, and diagrams that require precise lines and shapes. Examples of vector graphics software include Adobe Illustrator and CorelDRAW. Vector graphics are also easier to edit and manipulate than raster graphics, making them a popular choice for graphic designers. In summary, raster graphics are composed of pixels and are best used for photographic or realistic images, while vector graphics are composed of mathematical shapes and are best used for illustrations, logos, and diagrams. The choice between the two types of graphics depends on the specific requirements. Graphics programming involves using computer code to create and manipulate visual images and animations. Here are some basic graphics programming concepts. 1. Coordinate systems. A coordinate system is used to define the position of objects in a graphical space in 2D graphics. A Cartesian coordinate system is commonly used, where x and y values determine the position of objects on a 2D plane. In 3D graphics, a three-dimensional coordinate system is used, where x, y, and z values determine the position of objects in 3D space. 2. Graphics libraries and APIs. Graphics libraries and application programming interfaces (APIs) provide a set of functions and tools that allow programmers to create and manipulate graphics. Popular graphics libraries and APIs include OpenGL, DirectX, and Webull. 3. Drawing primitives. Drawing primitives are basic geometric shapes, such as points, lines, and polygons, that can be used to create more complex shapes and images. For transformations, transformations are used to modify the position, size, and orientation of graphical objects. Common transformations include translation, rotation, and scaling. 5. Colors and shading. Colors are used to add visual interest and detail to graphical objects. Shading is used to create the illusion of depth and texture. Common shading techniques include flat shading, Gouraud shading, and Phong shading. 6. Animation. Animation involves creating the illusion of motion and change over time. This can be done using techniques such as keyframing, interpolation, and morphing. 7. Rendering. Rendering is the process of generating the final image based on the graphical objects, transformations, colors, and shading used in the scene. The rendering process may involve complex calculations and optimizations to create a realistic and visually appealing image. These are just a few of the basic concepts involved in graphics programming. As with any programming discipline, mastering these concepts requires practice, experimentation, and a willingness to learn and explore. Thank you for watching. You stay tuned for next part.